Well, now let's look at leukopoiesis or granulopoiesis, the formation of the granulocytes. Here you see another image of bone marrow, and what we want to concentrate on now is the granulocyte, monocyte, progenitor cell lineage. The lineage is going to give rise to the granulocytes and also the monocytes. But as I mentioned earlier, I am only going to look at the formation of the neutrophil. The first cell that starts off in this lineage is the myeloblast. Again, it's a large cell, about 20 micrometers in diameter, and it's got a large spherical euchromatic nucleus. If you look carefully, you can see faint pale nucleoli, and the cytoplasm stains intensely basophilic, and this unstained portion is where the Golgi complex is located. The myeloblast differentiates into the promyelocyte, and this promyelocyte contains or starts to generate the factory that is going to make azurophilic or primary granules, which are in fact lysosomes. They stain here a dark blue colour. I say the word primary here because these granules appear in all the granulocytes, being the neutrophils, the eosinophils, and the basophils. But these three different granulocytes have granules that are quite different in their content as they differentiate into their respective cell types. So initially, this part of the lineage starts to accumulate these granules, and therefore they stain with the azure dyes. But they're yet to go through the differentiation into acquiring granules and the contents of those granules that are specific for the cell type. So this is a general cell, which we really are unable to determine which direction it will go into. Does it become a neutrophil, or a basophil, or an eosinophil? We can't say. Now, these azurophilic primary granules are only produced by the promyelocyte, so they'll be reduced in the progeny following cell division. The next stage of this cell is the myelocyte, and the specific granules will emerge. Again, those specific granules relate to the different roles that these granulocytes will have. For instance, the specific granule in a neutrophil contains antimicrobial substances or enzymes like collagenase that help digest the microbes in the bacteria that they are going to destroy and then ingesting into their cell cytoplasm. Whereas the eosinophils and the basophils will have specific granules for their particular role or purpose. Myelocytes initially have a spherical nucleus, but then, after a number of divisions, they have an indented nucleus. You can just see that indentation here. And notice the cell is now smaller. The cell then passes into the metamyelocyte stage. And the metamyelocyte stage is a very important stage of development because it's at this stage that the cell can no longer divide and the nucleus becomes kidney-shaped. Now, in the case of the neutrophil, that nucleus that was originally a kidney-shaped or a bean-shaped nucleus then develops further, and we call it a band or a stab cell. Look at this nucleus here, and you can see that it's a horseshoe-shaped or a U-shaped. This is an indication that the cell nucleus is going to be polymorphonuclear in appearance, that you see characteristic of the neutrophil. And at the same time that the nucleus is going through this differentiation process, two other things happen. Firstly, the granules start to become specific for that particular cell type because it's no longer dividing. It's concentrating on being the lineage to which it's destined to be. It's concentrating on creating the factory inside the cell specific for manufacturing the granules to be contained within that cell type. In this case, it's a neutrophil. And finally, that neutrophil or that nucleus will go through a stage where it becomes, as I said, more polymorphonuclear or having many forms and many shapes. Now, in a similar way, the eosinophil and basophil will acquire their respective specific granules and mature to the characteristic features of their cell type that we see in the bloodstream.